today's lesson, we're going to continue the topic of probability, but we're going to look specifically at expectation. If in your big books, you can write the heading Gwaith dosbarth, expectation and today's date. So expectation, this talks about the expected number of successes. So this is equal to the probability of a success times by the number of trials. There's two methods we can use to work out expectation, and it's totally up to you which one you use, or you may like to use a mixture of both depending on the question. So method one is like working it out as a fraction of an amount. First you work out the probability of it happening, and then you calculate the answer in step one as a fraction of the number of trials. Method two, multiplying fractions using our cross-cancelling. So again, we work out the probability of the event happening, and then we multiply the answer in step one by the number of times it's repeated using cross-cancelling. So we put the amount over one and then cross-cancel. So if we look at some examples then. Number one, there are 3 red beads and 2 black beads in a bag. A bead is picked from this bag 75 times and replaced each time. How many red beads would you expect to get? So if we do method 1, so first of all we need to calculate the probability of red. So P of red, probability of red, well there's 3 red beads and 2 black beads in the bag. So the probability of getting a red is 3 out of 5, 3/5. So by calculating it as a fraction of an amount, we can work out 1/5 first of all by doing 75 divided by 5, which equals 15. If you're unsure of that, you can always do a bus stop. 75 divided by 5. How many 5s are in 7? There's 1, remainder 2. How many 5s are in 25? 5. So then 3/5 equals our answer in step 1, 15, times by the numerator of the fraction, so times by the top number, which is 3. 15 times 3 equals 45. So that is your method 1, finding it as a fraction of an amount. So 1/5 first, dividing the amount by the denominator, and then 3/5 times in our answer by the numerator. Or, if you prefer method 2, this is our cross-cancelling method. So we still do exactly the same first of all. We work out the probability of red. So the probability of red is 3/5. There's 3 red balls out of 5 balls in the bag in total. Then all we do is multiply the probability of it happening, so 3/5, and we multiply it by the amount of trials. Well, they do this 75 times. Pop our 75 over 1 to make it a fraction, and now we can go about this as multiplying fractions or cross-cancelling. So looking for cross-cancels first of all, or any simplifies. So vertically 3 and 5, there isn't a number bigger than 1 that goes into these, so it's in its simplest form. Same this side, 75 and 1, there isn't a number bigger than 1 that goes into these. So we look diagonal for our cross-cancelling. Remember, when you're multiplying fractions, it's the bow tie method. So we can only cross-cancel diagonally, or we can simplify vertically. So we can see here, we've got a cross-cancel with 5 and 75. 5 goes into 5 once, 5 goes into 75 15 times. So we end up with 3 over 1 times by 15 over 1, which equals, now we've done all our cancelling, multiplying fractions, so we multiply the top two numbers. 3 times 15 is 45, 1 times 1 is 1. Never leave your final answer over 1. So our final answer is 45. We would expect 45 red beads if we repeated this 75 times. Okay, moving on to example 2 then. A dice is thrown 180 times. How many times would you expect to get A? So number 1, we got a 4. So the probability of a 4, so P4 equals, well, there's 1 4 out of 6 numbers. I'm going to use method 2. So 1/6 times by 180. Pop it over 1. Look for any cross cancels or simplifies where we can see we've got a cross cancel here with a 6 and 180. 6 goes into 6 once. 6 goes into 180. Well, it goes into 18 3 times. It goes into 180 30 times. So you end up with 1 over 1 times by 30 over 1, which equals 30 over 1, which is 30. So we would expect to have 34s. Next is asking us the probability, how many 3s we would expect. So again, P3, well, the probability is the same. There's still only 1 3 on the dice with 6 out of 6 possible numbers. So the chance is going to be the same. 1/6, the probability of it happening, times by 180, the amount of times we repeat the trial. Pop it over 1, where we can see we've got the same here, so we do exactly the same. Cross cancel, 6 goes into 6 once, 6 goes into 180 30 times. Multiply in the tops, 1 times 30 is 30, 1 times 1 is 1. So we end up with an answer of 30. Okay, C then, an even number. Well, even numbers on the dice, so probability of even, we can say. We know we've got 2, 4 and 6, so there's 3 even numbers out of 6 possibilities. So, probability of it happening is 3/6 times by the amount of times we're repeating it, times by 180. Pop it over 1, and now we look for our cross cancels, where we can see we've got the same here with 6 and 180. There isn't any with 3 and 1 or any vertical. So 6 goes into 6 once, 6 goes into 180, we know that's 30 times. Multiplying the tops, 3 times 30 is 90, 1 times 1 is 1. So we end up with 90. Okay? Or you could have done it that you simplified the 3/6 down to a half from the start and done a half times 180 and done it that way, okay? But we did the cross cancel here, so either way would be accepted. Next one then, the probability of getting a 2 or a 3. So first of all, P of 2 or 3 equals, well, there's 1 2 and there's 1 3 on the dice. There's 2 out of 6. Okay, so 2 6. Again, you could simplify it to 1/3 if you want, or we can simplify here, or we can cross cancel. Either way will be accepted. So 2 6 times by the amount of times we're repeating it, so we times it by 180, and we're popping it over 1. So this time, you may want to do the simplify here. So 2 goes into 2 once, 2 goes into 6 3 times, okay? And then you could then cross cancel again because 3 and 180. So, cross cancel, 3 goes into 3 once, 3 goes into 180. Well, 3 goes into 18 6 times, so 3 goes into 180 60 times. So we end up with 1 over 1 times by 60 over 1. 1 times 60 is 60, 1 times 1 is 1. Okay, so we'd expect 60 203s. Like I said, with this example, it doesn't matter how we cancel it down. Okay, so it doesn't matter if you do the simplify like I did here, or we could have done like the previous example, left this fraction as it is, and just do the diagonal cancel, the cross cancel straight away. Okay, moving on to number 3 then. In a game, this spinner is spun 60 times. How many wins would you expect? So, P of winning. First of all, the probability of winning is equal to, well, there's 2 wins out of 5 possible sections. So we're going to do 2/5. It's spun 60 times, so we need to multiply it by 60. So we pop our 60 over 1. Look for any cross cancels. Well, we can see 5 and 60 are a cross cancel as 5 goes into them both. 5 goes into 5 once, 5 goes into 60 12 times. No vertical simplifies on either, and there isn't any diagonal cross cancels here. The biggest number that goes into 1 and 2 is 1. So we end up with 2 over 1 times by 12 over 1, which equals 2 times 12 is 24 over 1, which equals 24. So we would expect to win 24 times. Final example then, number 4. The probability that a train will arrive on time the next day at Swindon is 0.8. If 60 trains arrive at Swindon the next day, how many will be late? So, first of all, we need to work out the probability of late. Okay, so P late is the same as the probability of it not being on time. Well, we know for it to arrive on time the next day, it's 0.8. And we know that all probability adds up to 1. So the probability of it being late is going to be 1 minus 0.8, which equals 0.2. Okay, sometimes they can give it to you as a decimal, as you can see here. It's not always going to be a fraction. So all we need to do now is multiply the chance of it happening. So 0.2 is the chance that it's late, and then it's 60 times it's repeated as there's 60 trains. So if we ignore the decimal point, multiplying our decimals, 2 times 60 is 120. One number after the decimal point in the question means we need one number after the decimal point in our answer. So it's going to equal 12. Okay, if you can copy all of this into your big books now, please. Thank you.